Hi guys, we're now gonna be proving an arithmetic series, right? So the Sn for the arithmetic series. We know what Tn, we know what the general term of an arithmetic series. We now want to know what's the general term for the sum of an arithmetic series. We know that the sum of an arithmetic series is given by Sn is equal to T1 plus T2 plus T3 all the way up to Tn. Now we want to know in general form how can we write a general or a formula for a sum of an arithmetic series. Why is that even necessary? That's necessary because if I ask you to add 15,000 terms, that's a lot of work to do it by brute force. So you probably would want to plug it in a formula and just get that. So let's see. To start off with, we need to note something. We need to note that we have our Tn, and the way we've thought about our Tn, we've thought about it as our last term. When someone says the nth term, you're talking about the last one, not the very last, but I don't know. Yeah, the nth one. So we already know that that's given by that, and therefore we would need that idea to try to prove what's going on here. So Sn is generally given by a plus b, plus a plus d plus a plus 2d. And that idea will carry on until the third last one. So where we can say the last term minus 2d plus the last term just minus d, that's the second last term, and finally the last term. Right, so the last term we can see it's our Tn. That could have been Tn over there. Just for you guys to note, that could have been Tn. I just choose to use the L for that. Now what we then do, we rewrite that in a different form. We flip it. Right, so what do I mean by that? I just mean we write Sn in a way that we start with the last term. So we have L plus L minus D plus L minus 2D and plus 2 plus, then we're going to have A plus 2D, and we're then going to have A plus D, and then we're just going to have A. Now we then choose to add them. We choose to add the Sn, the first Sn plus the second Sn, and this is what we get. So over here, the first two terms just going to be A plus L, and then the second two terms, the D's are going to cancel. We're still going to get A plus L. For the third term, the same thing is going to happen. We're going to get A plus L. For the, this is going to happen also here. We're just going to get A plus L. And over there, so it's just going to happen that we get A plus L n times. So we can write this Sn plus Sn as 2Sn. Then we can write this as AL, times n, because this is going to happen n times. So we're going to get this AL, and AL plus A plus L, A plus L. We're going to get them 10 times. Oh, sorry, not 10 times, n times. And therefore, our Sn can therefore be given as n over 2 A plus L. Now, the formula that you have here is the final formula for Sn. It is sometimes, Sn is sometimes given in this formula that you have. But if you want to substitute that L with something, you can, and we know what L is. So the other formula, which is the most common one, it's when we've substituted, where we will get A plus A. Remember, L is just A plus n minus 1 D. So therefore, they will just get n over 2, and then we're going to have 2A plus n minus 1 D, like that. And then that's our Sn term. Boom, done. We have proved it. Very tempted to do the geometric, but I won't. Thank you guys. I'll see you in the next video.